Good. Hello?
Hello.
Who's this?
That was Jared.
Why is he not?
I don't know.
Oh, no class?
Mm-hmm.
Was he here last class? He was here yesterday.
Was he not here last class? Oh, that's right. Yeah.
Oh, yeah, because we said
You're right,
that
yeah.
he's not here.
Hmm. Okay, so Allie, Jared. Who's missing? Zoe?
Zoe and Allie. No.
Allie's in the classroom. Noah. So Zoe and Noah are missing. And that's it?
Yeah, because
Zoe's up, so she's probably getting on soon.
She's tardy.
what do they even do if they're tardy?
I don't know. I just report it. I don't follow up on that really.
Say you're tardy.
I think it goes on your record, and if you get so many, something happens, but I don't really know. Okay, I could not log in. Oh, Zoe's here. Good. Did you take a picture? There I am, finally. Okay. So Noah's the only one. There we go, Noah. Okay. No one ever does the remote. No one ever checks in on remote. Well, he did, I guess, over the break. But he was like playing guitar. What is happening? All right. I'll put these over here, I guess. And I'll put one of these. All right, so, whoops.
Are we learning something new today?
We're doing factoring 2. I've gone over it once, but I was going to go over it again. And I was going to go over the next assignment too, just to put it in video so that you guys have it. You don't have to do the 2 of them today, but I thought I'd go over them both just so that the explanation is on the playlist.
Okay.
All right, so factoring quadratics 2. Well, let me see. I had a thing here. I'll remind you of what we did before. Oh, shit. Can't find my paper. Well, I'll make one up. Okay, so before with, whoa, the calibration is way off. That's what happened. Like I'm writing over here and it's like writing to the right of where I'm at. How do I calibrate this? 1 second. Sorry, guys. What's that? Yeah. No, this happens from time to time. Calibrate. Oh,
I saw a community about that. Oh, I about that. See, just about anyone.
Okay, hopefully that works. Okay, whoops. It's still not working. Still not working. What has happened? Anyway, I will do my best, but this is not working out well. All right, so before we had things kind of like this on a previous assignment. I'm sorry for my writing being so terrible. X squared, let's say minus x, geez, minus 6. So let's say we had this as a function. I'll just do the equals 0. It doesn't always have to have the equals 0. Wow, this is really bad. Yeah, this is factoring quadratic 1. This is kind of what was on 1, but I'll get to 2 in just a minute. So let's say you had something like this. You want to find when this function is 0. So the strategy is to factor it, and I'll show you the reason for that in just a minute once we do it. So the idea here on this type of problem, when all you have is an x squared, you don't have like 3x squared, 4x squared, you just have x squared. So that means the coefficient on the leading term. So again, the highest, so this is a second degree polynomial. We call them quadratics, but it's a second degree because its highest power is 2 on x. We call that the leading term. It's the most important term. It describes the behavior more than any other term. The other terms kind of just like affect it when it's close to the origin, when it's close to the middle of the graph. But when you go way out to the edges of the graph, this x squared term is going to be the one that's dominant. It'll drown out the effects of all the other terms. It grows faster than the others. So when you go to bigger numbers, this x squared term will be the most dominant. So we call it the leading term. The coefficients, like if I had a 3 here, whoops, this is hard. If I had like a 3 here, we'd call that the coefficient or the leading coefficient because it's the coefficient on the leading term. So in this case, the coefficient is 1. We don't write 1 because anything times 1 is itself, so we don't need to write 1. But technically, the leading coefficient is 1. In that case, when the leading coefficient is 1, it's easier to do this. It's easier to do the factoring. What our strategy is that this is way off. I factor 6 with pairs of factors. So any two numbers that could make -6, I want to come up with any pair of numbers that could multiply to -6. So it could be -6 and 1. It could be 6 and -1. It could be -3 and 2. It could be 3 and -2. Those are the 4 that it could be. So those are the possibilities that you can use. The one I'm going to choose is the pair that if I were to add them, they would make this number. Whoops. I'm sorry. It would make this number, which happens to be -1, this middle number. So I'm going to choose this one because -3 and 2, if I add them, add to -1. So that's the correct choice. If I added -6 and 1, I get -5, so that's not right. If I added 6 and -1, I'd get +5, that's not right. If I added 3 and -2, I'd get +1, that's not right. It's got to be the -3 and 2 because when I add them, I get the -1. I get that middle number. So I choose those two. So my factorization, I can turn this now, sorry for the sloppiness, into x minus 3 and x plus 2. So I've factored the left-hand side. What that means is I've turned it into a product. It's no longer multiple terms. It's one term with two things multiplied. So if I have something times something equals 0, well, anything times 0 is 0. So the solution to this is when either one of those is 0. So my solutions will be when x minus 3 is 0. That's one of them, because if that was 0, the whole thing would be 0. And also another one would be when x plus 2 is 0. Those are my two factors. And so when either one of those factors is 0, that would make the product 0. So that would make the statement true. If I add 3 to both sides, I get x equals 3. That's one of my solutions. And my other solution is x equals minus 2. So those are my two solutions to this equation. And that was from the previous assignment. That was from factoring quadratics 1. Because I have a 1 out here. Like I have no number in front of the x squared. So this is the strategy. This is how you do it. You come up with the pairs of numbers that multiply to the constant term, and you choose the one that adds to the linear term, the linear coefficient, -1. And then you pick those, you factor it, you set it equal to 0, you set each factor equal to 0, and those are your solutions.
Can we do one like that again?
Another one?
Yeah.
Sure. Let me try to, well, I'll do another one to the side here. Let me try to, my cursor is not where my pen is, so it's really not easy. Okay. Maybe I should use my mouse. Let's say I have, let me come up with one. I'll do x squared plus x minus 20 equals 0. Okay, so I need to factor the -20. That could be -20 and 1. That could be 20 and -1. That could be 10 and -2. That could be -10 and 2. That could be -5 and 4. That could be 5 and -4. I think that's all of them. That's everything it could be, pairs and number-wise.
Do we have to list all of these options? Or just like know them in our head?
I would list them just to be, just so that you, I mean, like if you get a pair that works, then you're done. Like, so no, you don't have to list them all. But if you can't do it like right in your head, then you might want to just list them all and try them all out and see which one works. If I added these, so I might be doing more than I have to do. Where the hell's, there it is. Jeez. So if I added these ones, I would get -19. If I added these ones, I'd get +19. If I added these ones, I would get 8. And this would be -8. And if I added these ones, I would get -1. If I added these ones, I'd get +1. This number is +1. So it's this pair that I'm going to choose. because I need it to add to 1. So now I'll factor it. Where's my cursor? X plus 5, X minus 4. So my solutions are when either of those is 0. So X plus 5 could be 0, and X minus 4 could be 0. So that's a solution when X is negative 5, and that's a solution when X is 4. Those are my two solutions to this. That's what, if I plugged negative 5 into here, I would get 0 on both sides. And if I plugged 4 into here, I'd get 0 on both sides. So those are my two solutions that make the statement true. Does that make sense? Okay, well, anyway, this is all being recorded, so I'll post this. You can follow along again later. What did I do? I think I cropped it or something. This is way off. Anyway, so on factoring quadratics 2, it's a little bit more difficult. I have one that says 4x squared minus 17x plus 15. And it doesn't say equals 0 on this one, so they just want me to factor it. I don't need to find the solutions. But I do need to break it into 2. A product of 2 linear bits. So when you have a number out front, it's a little more complicated. There's a few different methods that you can use. I'll post a link that has 2 other methods. They're pretty much the same, but I don't know which one. If you like a different method, use a different method. I don't care what method you use. This is just the method that I use. So what I would do is I want to factor this number again. So it could be 3 and 15. I'm sorry, 3 and 5. It could be 15 and 1. It could be negative 3 and negative 5. And it's going to be negative 15 and negative 1. I don't think there's other ones. Now, this number here in the middle is negative. So I know it's going to be one of the negative ones because I need to come up with a negative number. So I can't use the positives. That's not going to work. I need to make a negative number. So it's going to be one of these two. But when I have a number out here on the x squared, I have to factor that too. So this could be 4 and 1, and this could be 2 and 2. Now, technically, it could also be negative 4 and negative 1. I'll write those. Or negative 2 and negative 2. But over here, I'm not going to consider the opposites because there's like multiple ways that you can get the right answer. So you really don't have to consider the opposites. You really just have to do one set of them over on this side. One of those could work, but it would just give you an equivalent thing. So just so you know, over here, I would think of the negative versions, but over here, you really don't have to. It just makes it so that there's more than one way to solve it. So I just want to do one way. All right, I want to come up with negative 17. The way you do this, if you take a number over here times a number over here, and you add that to the leftover to the other multiplied by the other leftover. So let's see if I can do this. So I think 4 and 3 will make 12 if I multiply them. And then 1 and 5 will make 5. And 12 and 5 will make 17. So that's going to be my combination. So I think it's going to be this one. And this one. So 4 times negative 3 plus 1 times negative 5. That'll give me negative 12 minus 5. That'll make negative 17, which is exactly what I have in the middle. So you got to come up, so you got to take one from the left times 1 from the right, multiply them, then multiply the other leftovers, and then add those two numbers, and it's got to make the number in the middle. So it's a little more complicated when you have a number out front on the x squared. But that's what I do. This is how I do it. So those are my two pairs. The numbers that factored the 4 go in the front. So I will have something times x, something times x. These are my two factors. 4 and 1 will go in front. So here's my 4, and I'll put a 1 here. I don't need to write it, but I'll put it there anyway. Those first numbers go in the front. They go on the x. These last numbers will go on the right, but you got to pay attention. So if 4 goes with negative 3, well, when I FOIL, I do first, so I multiply this by this. I do outside this times that, and I do inside this times that, and I do last this times that. So it's always something from one side times something from the other. So if I want 4 to multiply with negative 3, I really have to put the negative 3 opposite the 4. I got to put it over here. That way they multiply when I FOIL. And so the negative 5 goes with 1, so I got to put it here. So even though the 4 goes with negative 3, you got to put them in separate bubbles, you know? That's part of it. And there you go. That's the factorization. 4x minus 5 times x minus 3. So it's a little more involved when you have a number out front. But, I mean, it's just a little algorithm you learn and practice. But that's one of them. I'll do another one. Yeah. Let me write it like this, maybe. So I'll do in red. I'll put 3 here. Maybe in green, I'll put plus 8. And they want us to factor this. So I'm going to come up with the factors of 8. That could be 8 and 1, negative 8 and negative 1. And I need a negative, so it's going to be one of the negatives. It could be 4 and 2, or it could be negative 4 and negative 2. So knowing that it's got to be negative, I can pretty much cut these out already. It's going to be one of the negatives. I also need to factor 3, which is prime. So it's 3 and 1. That's it. Okay, so how do I make negative 10? I think it's going to be 3 and 4 make negative 12. And then 1 and negative 2 make negative 2. That's not right. So, well, now I'm having trouble with this one. Factor. Yeah, you wrote that right. I guess it's going to be 3 and negative 2 makes negative 6. And then 1 and negative 4 make negative 4, and negative 6 and negative 4 will make negative 10. So it's tricky. You got to think about it. So it's going to be this one and this one. So I'm going to have, I'll do blue again. So the red numbers are going to go in front here. So 3 and 1. They go in the front. And then the green numbers will go over here. I had to put 3 with 2 to make negative 6. So I'm going to put the negative 2 over here. So it multiplies with the 3. And then I'm going to put the negative 4 here. So it multiplies with the 1. Because if I do 3 times negative 2 plus 1 times negative 4, I get negative 6 minus 4. That makes my negative 10, which is what I need. So that's the factorization. That's it. That's what they want. Is this okay? You guys kind of follow this? It's tricky. Like, I mean, it's a lot of steps, but it's a pretty important thing for Algebra 2, actually. Any questions? Okay. Well, actually, I said I'd do the next assignment too. Since this is kind of complicated, maybe I'll just leave it here just so that you guys don't get confused. But that's how you do those. So the first one, from the factoring quadratics 1, you just have to factorize the last number and figure out which pair adds to the middle number. And then when you have a number out front like this, it's a little bit more complicated. You have to factorize the first and the last numbers and figure out the way that you combine them to make the middle number. But it's kind of similar. Is that okay? Okay. Did somebody, I heard a noise. Are you guys good at home? Okay. All right, well, if you want to just work on those assignments and ask me questions, that's all I need from you. All right? And, oh, if you were at home also, you'll notice I have a polynomial assignment up. I've pushed that back a couple times, and I'm going to keep pushing it back. There's still more we have to do with quadratics, so even though I posted that, I haven't explained that yet, so don't feel like you have to get right on that. That'll be a future assignment. And it's a longer one, but I don't think, I'll go through it with you. Oh, if you haven't done your check-in forms, would you do those, by the way? Mm-hmm. Like, I guess I'll end the recording now and post that.